Okay, so in this video, we are going to create a timeline. A timeline is where we fill in the blocks of time for each task in a job. We see that this digraph illustrates all of the tasks in a project, and we read it from left to right, so from start to end. And anything that is attached to start may be scheduled right away with our workers. Anything after that, these are called preceding tasks. So task B could not be started until task A has been completed. Or task F cannot be started until both task B and task D have been completed. So we want to start scheduling our tasks for our processors. We see that we have two processors here, processor 1 and processor 2. Processors are our workers. They can be people, they can be machines or computers. We don't know what they are, but we know that we have to schedule work for them. As I come down here to the priority list is the order that we would like to schedule the tasks in. Sometimes that's not possible because, for example, task F is first in the priority list. We see that we cannot possibly do task F first if both task B and task D must be done ahead of time. To give us a concrete example to illustrate this, I cannot put, let's say task F is the roof on a house, until both the walls of the house and the foundation of the house have been built and maybe the rafters of the roof. So if these are all tasks that must be done in the construction of a house, we see the roof can't be put on until after the walls and the foundation and the supports are in place. So we don't know what these tasks are. That was just an example to say why it's important to make sure the preceding tasks are done first. So we've just established we can't do task F first. So then we look, can we do task A first? Can I skip over this task and go to A? And we say, yes, A is attached to the start vertex. That means it may be started anytime. So for the sake of making this video quick and easy to put together, I've made the tasks in different colors and they are sized appropriately. We see task A is 5 units of time, task B is 3 units of time, and they are appropriately sized. They are proportionally sized, I should say. So I can take this first task A and I can give it to either one of my workers, either processor 1 or processor 2. So I've decided to give processor 2 task A to complete, and once I've done that, I need to cross it off my list. And after you complete a task, you always go back to the beginning of the list to see are there any tasks in the beginning of the list that can now be done. That's the purpose of calling it a priority list. These tasks take priority, so get them done as soon as possible. I look at my digraph, I see that task F still cannot be started because neither task B or task D have been completed. So we're going to have to skip over F. A is already completed. We say, can I assign task B to my other worker? My other worker is ready to go back here at time 0, and we see processor 2 has work to do from time 0 through time 5. Processor 2 is busy, cannot take any other work right now, but processor 1 is waiting for a first task to be assigned. And we see we can't give processor 1 task B, and that's because B cannot be started until A is completed. And A will not be completed until time 5, so the soonest I can assign task B to any worker is at time 5 or later. So we skip over task B and we say, can we assign task C right away to worker 1? And we see C is attached to the start vertex. That means there's no preceding task. It may be started right away. So I'm going to take task C. I'm going to assign it to worker 1. And we see that worker 1 is busy from time 0 through 13. I can cross that off of my list now, saying it's been assigned. And again, we go back to the beginning of the list. We say, can we start task F right now? And F cannot be started because neither B or D have been completed. So we go to the next available task in the list. A has been completed. B is ready to be assigned. B can be assigned as soon as A is completed. We see that worker 2 will finish task A at time 5, so task B can be placed right after that one. So now worker 2 is busy from time 0 through time 8. I can cross B off the list. I go back, I say, can I do F now? And I say, well, no, because only B has been assigned. D still has to be assigned. So we look and we say, which worker is going to be ready to take a next task on first? And we see that processor 2 will be ready at time 8. Processor 1 won't be ready until time 13. So this one will be ready first. Can we assign the next task in the list? We see that F can't be assigned yet because it still needs D. Can I assign D right here? We say, well, yeah, D just needs A to be done. And A was completed back here at 5, so yes, we could put task D here. So we've assigned task D. Worker number 2 is now busy from time 0 through time 10. I can cross D off the list. And I say which worker is going to be ready for their next task first. We see that is, again, worker 2. Processor 2 is ready for a task at time 10. We go back to the beginning of our list. We see that F is waiting to be assigned still, and B and D have both been assigned and completed by this time, so task F could be placed here at time 10 for processor 2. We're going to take F and put it there. We now see that processor 2 is busy up until time 14. Let's cross F off the list. Next on our list is E. E cannot be started until C is completed. We see that C gets completed here at time 13, so E can go right after that task. So processor 1, as soon as they finish task C, can immediately start task E. We see the graph shows us that, and we'll be busy until time 16. I can cross E off the list. And the last task is G, but G cannot be started until E has been completed. That means I can't put G here because E is still being worked on in these two blocks. The soonest that G can be assigned is at time 16. And it doesn't matter if I give G to processor 1 or to processor 2. I'll just place it here to divvy up the work, but that's not required for scheduling purposes. And now we want to cross the last task off the list. Once you've done that, you say the project is completed. Well, how long did it take to complete the project? We see it gets completed at the 17th unit of time. Whether that time is measured in days, hours, weeks, it's the 17th unit of time is how long the project takes. And in the process, it had what we call idle time. I had 2 units of idle time for processor 2 and 1 unit of idle time for processor 1. And these are the 2 numbers that we're interested in. How much idle time was there, and how long does it take to finish the task? And that's it. Then we've completed the problem.